Okay, good morning. Good evening. This is Professor David J. De Los Reyes. Sorry for that one. It's good evening, okay? It's October 8, 2023. The time is 10:06 p.m. October 23, oh, October 8, 2023. Okay, my topic for tonight will be college algebra. This is a long video format discussion. Okay, let's proceed. This is a new topic under college algebra and we are almost done. I think this will now be the last topic under college algebra. I just brought out this topic because this topic is actually very important under the study of integral calculus, that is in the so-called integration using partial fraction. Without knowing the so-called partial fraction equivalent of a certain fraction, okay, it's hard to integrate. So under the study of integral calculus, there are variation of problems which are only solved by what you call this using partial fraction, and actually there are 4 cases of partial fractions. Okay, let's proceed. College algebra lesson number 85. The title of the topic will be partial fractions. There are 4 cases of partial fractions. The cases are number 1, 2, 3, and 4. Number 1, linear factors, meaning the given denominator of the fraction contains linear factors. Linear meaning the highest power is just 1, so it's linear, right? Number 2, if the fraction involve repeated linear factors, they are linear factors but they are repeated. The attack for that problem will be different from the previous linear factor. Okay, repeated linear, this is repeated linear factors. Case number 3. Case number 3 is the denominator of the fraction involves a quadratic factors. Quadratic factors meaning the highest power will be maybe x squared plus 2x plus 3. Okay? If you could not simplify this one into 2 simple linear factors, you could not do anything about it. Right? So this falls under the so-called fraction involving the denominator quadratic factors. Okay? Case number 4, this is the worst case scenario. Repeated quadratic factors. It's still a quadratic factor, but this is repeated. Maybe like that, to the second power. So actually, this solution is more what you call this complicated than the previous 3. Because this is the so-called worst case scenario under the so-called study of partial fraction. Okay, for tonight, for us not to overload our minds, I will just discuss the first case. Okay, so we could easily grasp the so-called concept on how to perform case number 1. For case number 1, okay, linear factors. This involves only the denominator. Okay? The location of the linear factors is in the denominator. Okay? So if we try to bring out the setup of this one under linear factors, the given partial fraction will be an 1 over the quantity x minus a times x minus b. Okay? To get the partial equivalent of this one, if there are 2 linear factors, there will be 2 coefficients here on the right. It is a and b. Meaning to say, to get the equivalent partial fraction of this one, we must have to compute for a and to compute for b. And this e here is under the first linear factor, and this b here is under the second linear factor. Okay, so the setup for the form under case linear factors is this one. Okay, so memorize this by heart. If there are 3 linear factors, okay, Of course, the right hand side, there should be a plus another constant c all over the third linear factor x minus c. Right? They are all linears, so if there are two, there will only be two partial fractions on the right. If there are three partial fractions on the left hand side, there should be three. So you adjust the, what you call this, form properly, okay? So I will erase this one because the one I give you is just two linear factors, okay? So it will be an unknown constant a over the first linear factor plus unknown constant b over the second linear factor. Okay, let's try to bring out an example so we could visualize the concept of the so-called linear factors solution. Okay. Example. Find the equivalent partial fractions. We are given an equation, algebraic equation, 1 over the x squared minus 2x minus 8. And what will be the partial equivalent of this one? Partial fraction equivalent. Our topic for tonight is under linear factors. So supposed to be, if I give you a quadratic equation, this quadratic equation could be factored into two simple linear factors. So if we try to bring up the solution, x squared minus 2x minus 8, x squared minus 2x minus 8, this should be a product of a two binomial, right? First binomial, second binomial. The product of x and x is actually x squared, right? And the product of positive 2 and a negative 4 will be a negative 8. Right? So we are correct with that one. So the only problem now is we check the value of the middle term. The middle term is 2 times x is actually 2x, the middle term. And x times negative 4 is negative 4x. This is the value of the middle term. They are similar terms, right? A 2 minus 4 will be minus 2, okay, x. So the middle term, with these two given binomial factors, okay, if we try to verify the value of the middle term, it is negative 2x. And this negative 2x is actually this one. So if we try to simplify this one into two binomials, it will be the product of the quantity x plus 2 times the product primes the quantity x minus 4. So if we try to rewrite this one now, okay, and this is 1 all over, I know the linear factors of this to be quantity, the product of x plus 2 times x minus 4 from this, right? And according to our concept, if there are two linear factors, there should be two unknown constants on the right. This will be a over the first linear factor, which is x plus 2, plus b over the second linear factor, x minus 4. Okay? And if we try to simplify this one, this now involves fraction, right? Right? What will happen? The left hand side, it will just be simply 1. Okay? All over this. Right? And the right hand side, we use the butterfly method. We take the product of this, that is a times the quantity x minus 4, plus the product of this, b, times the quantity x plus 2. Okay? And the resulting product now will be the product of x plus 2 times x minus 4. This is multiplied by x minus 4 already. This multiplied by x plus 2. Right? So we can cancel this one now, right? We can cancel. The operation here is multiplication. This is multiplication. Right? We remove this one. We remove this one already. So what comes out, if we try, after using the butterfly method, the denominator is gone, right? The denominator is gone. So what comes out is just 1 equal to a times x minus 4, this one, plus b multiplied by quantity x plus 2. And if we try to simplify this one, ex, b times a is bx, minus 4 times a is minus 4a, b times 2 will be plus 2b. So this is the final linear equation, okay, in order for us to compute for the values of a and b. Actually, there are two solutions in the computation for the value of a and b here. But I want you to learn the so-called equating coefficient of like terms. This is the proper way. But there is the so-called expedited solution. Expedited. The next time around, I will teach you. Okay? To compute for the value of a and b, we use the method equating coefficient of like terms for both the left and right. Right? So we will start with terms that involves x to the first power. On the left hand side, it is 0. Right? This is just 1. I will write it like this. 1 plus x to the first, right? X to the first multiplied by 0. X to the first multiplied by 0 is actually 0. There is an x term, but unluckily the coefficient is 0. It is 0. That's why when I equated coefficients of like terms, meaning all terms on the left with the value x to the first power equal to the value of x to the first on the right. For on the left hand side, the coefficient of x is actually 0. So I put it here, it is 0. Right? On the right hand side, all the terms that contains the x term, okay, we'll just take the coefficient. So this is a. Right? What's the coefficient of this? An x term, right? This is the coefficient. So we'll just take the coefficient. Right? How about minus 4a? No x term. It's a pure constant. Because a here is a constant. 2b is still a constant. It does not contain an x term, so we don't include it. So for the power x to the first power, 0 equal to a plus b, or a is equal to minus b after the transposition. We call it equation number 1. Okay? What's next? The next power of x, which is less than 1, is actually 0. We will equate all values of x to the 0. X to the 0 is actually equal to 1. All pure constant terms on the left. Meaning to say, if we are equating values of x to the 0, all constant terms on the left should be equal to the value of constant terms on the right. So on the left hand side, this is 1, right? So this is 1. On the right hand side, we are done with this ex and bx, right? Minus 4a is a constant, so this is minus 4a. 2b is a pure constant, it's 2b. We call this equation number 2. Okay? So to compute for the value of a and b, we are given two linear equations involving a and b. So solving simultaneously, you could either use the so-called solution by substitution, or solution by using elimination by subtraction, or solution by using elimination by addition. So I will use what you call the substitution. Okay? I will go to equation number 2. So 1 equal to minus 4 times a. But what is a in terms of b using equation number 1? It is minus b, right? Plus 2b. After the substitution, the only unknown now on the right is actually the capital letter B. So 1 will be equal to, this is a minus, and a minus, it will not be plus, right? Plus 4b, plus 2b, which is 6b. And b now will be equal to 1/6. Okay? And the value of a, using equation number 1, it should be negative 1/6. Okay? This is the solution I would like you to learn. That is, after arriving at this equation, to solve for the unknowns, you equate coefficient of like terms. And the procedure on how to do it will be this. Right? So the given equation, 1 over x plus 2 times x minus 4, the equivalent partial fraction of this will be a, which is negative 1/6, over x plus 2, plus the value b, which is 1/6, all over x minus 4, and that will be our answer. Okay? So that's the way how to, well, call this, get the equivalent partial fraction of this if the factors on the denominator are all linear. It's not repeated, it is just simply linear, right? Because under the study of integral calculus, there could be a problem that you will integrate this one, right? Of course, this should be with the dx. And to integrate this one, okay, since the left hand side is equivalent to this, it will be equal to the integral of the first one, equal to the integral of the second one, and for the solution of this, it's an AC1 already. And for the solution of this, it's an AC1. Right? So meaning to say, to integrate this one, I'm bringing you to integral calculus. I am telling you the importance of partial fraction. Because if there is a problem in integral involving this, to integrate it, you must have to compute first the partial fraction equivalent before you could integrate it easily. Right? So this is very easy to integrate, and so with this, when you reach integral calculus. Okay guys, that's the way how to bring out the equivalent fraction of a given fraction if the denominators involve linear factors. If there are two linear factors, there will be two coefficients on the right. If there are three, there should be three. If there are four, there should be five. Okay, so it depends. Okay, good evening from Los Angeles. This is Professor David G. De Los Reyes, the topic partial fraction, linear factors. Good evening.